warm welcome to our studio guest today and to fellow travelers out in cyberspace, thanks to that non-stop stream of the zeros and ones. My name is Peter Gobets, co-founder of the Zero Project and moderator of the International Conference/Workshop on Zero. The Zero Project is a three-stage affair. There's a book project, an associated online event, and the in-depth research program to follow. Today, session 24. Professor Sudip Bhattacharyya, astrophysicist, Tata Institute of Fundamental Research in Mumbai, India. He will investigate the plausible philosophical ideas which could have given rise to the number zero. And interestingly, he argues that neither the place value number system nor a placeholder in such a system was required to conceptualize zero. We've not heard that thesis before, and we're very curious to hear more. Our panelists appeared as speakers in earlier sessions. Professor Joseph Bielo, University of California at the Davis campus. Professor Mayank Vahia, formerly of TIFR, also Tata Institute in Mumbai, who introduced us to Professor Bhattacharyya, for which our thanks. And Mr. Ganapathy Subramaniam, an artist working at the studios of Lalit Kala Academy, National Academy of Art, Ministry of Culture in Chennai, India. We owe our introduction to Ganapathy to none other than Dr. Robert Lawrence Kuhn, close collaborator of the Zero Project. Dear Sudip, please introduce yourself briefly and tell us about your article contribution to the monograph on Zero, please.
Hello, I'm Sudip Bhattacharyya in Tata Institute of Fundamental Research in Mumbai, and I have written an article on zero and its possible origin, and I'm going to present that during my presentation now. So you can start with the first slide. Greetings. I thank the organizers for inviting me to give this presentation. I will briefly discuss what background condition could have given rise to the mathematical zero and if zero could have been originated in India. This is the next slide. My presentation will be a mixture of facts and some speculations and my views, and it is based on this paper. It's a peer-reviewed philosophy paper that I have published last year, and also another paper which I have written for the Zero Project. At the beginning, let us decide what zero we consider. Typically, zero is talked about in a very broad sense, and then it is very difficult to probe the origin of zero. So we consider the mathematical zero, which is an independent number with a set of basic operations defined. While zero represents nothing, I make a clear distinction between this mathematical zero and nothing. This zero is not nothing, is an existing mathematical object. What do we study and why? We investigate if philosophical ideas of nothing could have given rise to this mathematical zero. More generally, we discuss what kind of need and what kind of cultural background could have given rise to this mathematical zero. This investigation should be complementary to other studies, for example, based on epigraphic and paleographic evidences to probe the origin of zero. This is next slide. So zero represents nothing, but what kind of nothing? In this paper, I have very systematically and clearly classified nothing into four distinct categories: balance, absence, emptiness, and non-existence. And if zero represents nothing, we need to know which of these nothings makes the foundation of zero. So here is a little bit of details about all these four nothings. First, the balanced nothing. It's a balance of a few, two or more things. For example, here are some examples. For example, k minus k could be a balanced nothing. Two forces which are equal and opposite to each other would be a balanced nothing. The unmanifested fundamental substance prakriti of the Indian philosophical school of Shankha is another example of balanced nothing. And the fluctuating vacuum considered in modern physics could be a balanced nothing. Thus, a balanced nothing is a secondary to multiple existence and is an existent itself. Then an absence nothing implies the absence of a specific thing. It is also a secondary of that thing which is an existent and hence an existent itself. Emptiness nothing does not require an absence, but it requires a container, which is the primary and an existent. The examples can be empty glass to empty space to mathematical empty set. For this, glass, space, and set would be the container respectively. And it is also an existent. And finally, the most fundamental one, the non-existence nothing, it is the absolute non-existence. Now, the first very important question to probe the origin of zero: did mathematical zero originate due to a practical need? Was there a need in daily life, mathematics, natural science, technology? For daily life, one does not need to consider the growth, measurement, building, buying, or selling of zero amount of anything. Thus, an independent number zero representing nothing is not required in daily life. For mathematics, zero was essential for the development of the current sophisticated and advanced mathematics. It's true, but one could not have foreseen this before zero's basic mathematical operations were invented, and certainly not before zero was conceived as an independent number representing nothing. And science and technology, while many aspects of natural science and technology cannot be imagined without zero at the current time, the use of the mathematical zero in these disciplines has been a relatively recent phenomenon. For example, a number of ancient civilizations made a spectacular progress in technology without the mathematical zero. So neither zero came out from these technologies, nor these technologies required mathematical zero. Thus, I would say zero was likely conceived without a practical need. But what about place value number system and placeholder? In the place value number system, which was originally invented by the ancient Mesopotamians, the position of a digit in a number determines its value. A connection between the place value system with zero is commonly made, almost implying that zero owes its existence to this system. But is it really true? Was the place value system required for the conception of zero? We test this in the following way. Note that the place value number system is a highly compact, systematic, efficient, and operationally manageable way to handle big numbers using only a few symbols and numerals. But this system is not fundamentally important for the concept of numbers. So let us consider the following extreme case, which is impractical but notionally possible. That is, each natural number is denoted by a single unique symbol. This means that there are infinite number of symbols. Each natural number is denoted by a single unique symbol. Even in such a rudimentary number system, we can easily understand that zero could be included as an independent number in the number system, in this number system, and its basic operations like addition, subtraction, multiplication, etc. could be defined. Thus, zero is independent of a specific number system. Therefore, clearly the conception of mathematical zero does not require the place value number system. Since the Mesopotamian placeholder was required only in the place value number system, the conception of the mathematical zero does not require the placeholder either. But would the placeholder at least give an idea of the mathematical zero? Note that Mesopotamian placeholder was only a separator or a punctuation mark and did not represent the emptiness nothing. This could be understood from the following. Mesopotamians never used the placeholder at the end of a number, such as 60. They would not mention 0 at the end, where 0 should have appeared, and this is the reference. The placeholder was not used as an independent number. And a mere punctuation mark or separator like comma or semicolon should not have stimulated the idea of 0. Thus, it's my view that it could be misleading to bring in the place value number system and the placeholder in order to probe the origin of 0. If a practical need did not give rise to the mathematical 0, as I have argued, then it must have been conceived purely intellectually. What could be the intellectual source of 0? 0 implies nothing, and hence it is expected that a philosophy of nothing would stimulate the idea of the mathematical 0. So I come back to the question, if 0 represents nothing, what kind of nothing it is? It cannot be a balanced nothing. I already mentioned 4 kinds of nothing. It cannot be a balanced nothing like k minus k. And I have given here 2 reasons. If k minus k equal to 0 defines 0 with k as any number, then 0 is defined non-uniquely and is not an independent number. This is like defining number 7 non-uniquely by 1478 minus 1471 or infinite number of pairs, subtractions. So if 0 is an independent number, this is not the way 0 can be defined. So 0 cannot be balanced nothing. Also, the natural numbers cannot be defined by a subtraction from one from another, because then the subtraction of the natural numbers has to be defined before the natural numbers. So subtraction would be primary and natural numbers would be secondary, which will be a self-contradiction. And secondly, moreover, one cannot conclude k minus k equal to 0 without a prior understanding of 0 as nothing. Therefore, k minus k cannot define 0, as the concept of 0 should be the primary and k minus k equal to 0 should be a secondary. If 0 would be defined by the absence of a thing, for example, any number, in a non-unique way, then 0 would not be an independent number either. Similar for emptiness nothing. Thus, I conclude that a notion of absolute non-existence or the non-existence nothing perhaps provided the conception of the mathematical 0. So it is perhaps the absolute non-existence which is possibly the philosophical foundation of the mathematical 0. Now I come to the philosophical origin of 0's basic operations such as addition, subtraction, multiplication, etc. The first record of 0's basic mathematical operations is found in the book Brahmasputra Siddhanta. Brahmagupta, an Indian mathematician and astronomer, wrote this book in 628 CE. 0 attained the full status of a number due to these operations. Such operations, in my view, would not have been invented without a philosophical premise of nothing, and we'll see that here. 0's mathematical operations are different from those of other numbers, as we all know. It's somewhat different. It puzzles people typically, and hence did not directly follow from such operations of non-zero numbers. Let us consider first addition, subtraction. For non-zero numbers, the concept of increase, decrease is the primary, and addition, subtraction is the secondary. We understand this, that not only humans but non-human animals would have some idea about increase and decrease. But the addition and subtraction is a quantitative measurement of increase and decrease, which requires a particular operation which was discovered, which was invented possibly in the very early phase of civilization, only a few thousand years ago. So increase, decrease is the primary and addition, subtraction is the secondary. But for 0, addition, subtraction is the primary because there is no increase, decrease. And its rule could not be ascertained without a philosophical premise or a conception of nothing. Moreover, since there is no change due to addition or subtraction of 0. At the beginning, when it was invented, such operations might not have any practical need. This supports again my earlier conjecture that the zero's origin did not require any practical need. Then I come to multiplication. Unlike non-zero numbers, 0 converts all numbers to itself by multiplication. Why is c into 0 equal to 0? Sometimes this is proved in this way. But this is not proper, because as I have already argued that this k minus k is secondary to the concept of 0 and hence does not define 0. Rather, c into 0 equal to 0 would have been premised from the philosophy of nothing in the following way. Note that c into 5 means 5 c's. Similarly, considering 0 is nothing or no, c into 0 implies no c's or no c, that is nothing, or mathematically 0. Now I come to the some cases for the Indian origin of the mathematical 0. There are many evidences of this, but I will mention only two: philosophy of nothing and word numerals. So we have already mentioned that 0 requires a philosophical base of nothing, and this concept of nothing is deeply entrenched in Indian culture and philosophy. I will not go into details, but I will very briefly mention some examples. For example, Nasadiya Sukta or Hymn of Creation of Rig Veda, an ancient Indian book, which might have been composed before 1000 BC, mentions non-existence as written here. Also, Nirguna Brahman or absolute without qualities, which are mentioned in several Upanishads, another set of ancient Indian books of philosophy, might be somewhat close to non-existence, nothing. I have already mentioned that the unmanifested fundamental substance Prakriti of the Shankha philosophy can be an example of balanced nothing. And the Indian Buddhist school, the Shunyavada, which literally means the theory of or ism of emptiness, argued that everything is empty. This Indian philosophy of nothing is still valued in Zen, which is very popular, and some other sects of the Mahayana Buddhism in multiple countries, and provides a living evidence of the philosophical background of the mathematical 0. So in India, there was a philosophical background for the origin of 0. And then I come to another interesting topic. Another very interesting living evidence of the Indian origin of the mathematical 0 is word numerals. What is this? This is a way of expressing numbers by specific words which are arranged according to the place value number system. Word numerals were developed in India likely in the early centuries of the Common Era. Many words were assigned to represent each of the numbers from 0 to 9 and sometimes even larger numbers. Thus, Chandra, which means moon, is one of the words representing 1 because moon is unique. Similarly, Paksha, which means fortnight, is one among many words representing 2 because there are 2 fortnights in a month. There are a number of words to represent 0 as well, such as Shunya, which means emptiness, Kha, which means sky, and Bindu, which means point, etc. Why was a word needed to express a numeral? This was a cultural thing. This is because in ancient India, it was customary to compose or write results and conclusions of scholarly works, including those of mathematics and astronomy, in verse. But we should remember that word numerals are not words. They are actually numerals, represented by words only due to the cultural reason. And how do we know this? Because not only their arrangement is according to the place value system, but also they have right to left arrangement. That is, the least important digit is mentioned first. The latter is particularly suitable for mathematical operations because basic mathematical operations such as addition, subtraction, multiplication start from the least important digit. This indicates that word numerals would be used for mathematical calculations. An example of such an arrangement of word numerals can be found in the ancient Indian astronomy book Pulisha Siddhanta. This is just one example among many. So look at this word, look at this number written in word numeral, kha, and in the bracket the numeral is given, kha, kha, ashta, muni, rama, artsvi, netra, ashta, shara, ratripa. So these numbers are given, these word numerals represent a particular number, and this is this number. Remember, the least important digit is mentioned first. So this is the least important digit. So it goes here. So you have to read in the opposite way, 1, 5, 8, 2, 2, 3, etc. Here we note that unlike the Mesopotamian placeholder, 0 was used at the end of a number. In Mesopotamian, placeholder was never placed at the end, indicating that this 0 was not a mere separator or placeholder. Moreover, given that there are several words to represent 0, like for numbers 1 to 9, and that all these words for 0 suggest nothing one way or another, one may conclude that this Indian 0 is an independent mathematical number founded on the idea of nothing. Thus, this 0 in the form of a word numeral, like this word numeral kha, is the same mathematical 0 we consider. Why are word numerals important? Ancient Indian mathematics books typically do not include calculations using symbols or numerals, usual numerals, due to cultural reasons, as I have mentioned. Even Brahmagupta, who gave the rules of zeros basic operations, addition, subtraction, multiplication, etc., as I have mentioned 0 as kha, which means sky, akasha, sky, and shunna, emptiness, etc. Thus, that word numerals are actually numerals, and 0 in the form of word numerals like this is really the mathematical 0 are extremely important to probe the origin of 0. We cannot ignore this. Another main attraction of word numerals is, in order to probe the origin of the mathematical 0, is that they are a living system continuing without an interruption for almost 2 millennia in India. They are taught to children in India even today. Word numerals for numbers, including 0, have been popular in multiple languages in India. And as you know, India has many, many languages and cultures, and are deeply entrenched in the diverse Indian culture. This continuity makes their interpretation more reliable. However, word numerals were not the only way the numbers were represented in India. There are also usual symbols or numerals in India. For example, those given in the Bakshali manuscript of the first millennium CE. And here is 0, like a point. Here is another Indian culture in Cambodia of 683 CE, and here is this 0, again like a point. And the first example anywhere in the world of a 0 as a hollow circle, like our 0 that we use today, is found in this temple, in a temple in Gwalior in India, that dated 876 CE. Thus, both hollow circle and point were in use to represent 0 in India, which are consistent with the word numerals shunna, which means emptiness, hollow circle, and bindu, which means point, 0 dimension, respectively, representing the mathematical 0. Such numerals, while not used in books in ancient times in India, should have been used for day-to-day calculations performed using dust sprayed on a board or on the floor. This is why mathematical calculations were known as dhuli karma or dust work, and arithmetic is still known as patiganita in India, where pati means board and ganita means science of calculation. Now I come to the last slide, the summary of my presentation. 1. The mathematical 0, which is an independent number with its basic operations defined is distinct from the general idea of nothing. Nothing can be classified into four categories: balance, absence, emptiness, and non-existence. A practical need perhaps did not motivate the conceptualization of the mathematical zero, which implies that purely intellectual activities gave rise to zero. The place value number system and the placeholder might not have a role in the invention of the mathematical zero. The invention of zero required a prior philosophical base of nothing, most likely the non-existence nothing. The basic mathematical operations of zero were premised also based on non-existence. This is my view, of course. The philosophy of nothing and word numerals are two living evidences of the Indian origin of the mathematical zero. And here I stop. Thank you.
Thank you, Sudip. Thank you very much. Clear exposition. Something we're going to have to factor in because there are a lot of contending views about this. So I hope you'll bear with us. Maybe, jump into the fray also, and let's see whether we can reach any kind of consensus. But thank you very much for this very clear, exacting presentation. Joe, you've heard this, and I know you're not an historian of mathematics, but it must still be intriguing to see zero's adolescence and adulthood appearing out of the mists of history. Did it raise any questions on your part that you might like to pose to Sudip?
Oh, yeah. So, absolutely. I had a bunch, actually. I wrote some down. Sudip, I just wanted to say I really enjoyed your talk. It was really clear, and I like the way you definitely clarified different issues in which sort of were sitting there in my mind, but I think you clarified them for me. I have just first is just a basic question of fact, and then a couple of sort of bandied about kind of questions, if you don't mind. You just made a comment about, because you distinguished the Indian use of zero as that it did use it, they did use it as a placeholder versus the Mesopotamian, for example. What would happen when in Mesopotamia they would represent 60 as an example? You said they wouldn't use a zero, in the sexagesimal system. How was that represented? I didn't know.
So as you know that, of course, I got it from the book which I have referred. So as you know that in sexagesimal system, 60 would be 10, right?
Would be.
Yes, it will be 10. And if you omit 0, it will simply show as 1. So they would not be, they must have some way to differentiate between 1 and 60 by context, but there was no other way if they write them in numeral. Of course, if they write in word or if they work it out on abacus, that is fine, which they used to do all the time. But if they had written it in numerals, then there was no way to differentiate between 1 and 60 for them. But they must have differentiated using context.
But when they were writing them on cuneiform, were they, how do you do that with context? I don't know. I'm just, I remember looking at some cuneiform when I was doing my study.
You see that they always used the context. See, their place value system started, I don't know exactly when, but it's almost around 3000 BC. But they started their placeholder symbol, particular symbol for placeholder, only when this later Babylonian this kingdom came up, which was around between 300 and 600 BC. So for more than 2 millennia, they actually managed without any symbol for placeholder, but just with a gap. And often it happened that this gap would not be very clear. So they managed with the context. So they would understand from the context. They were expert in that. They must have managed with the context. Okay.
And then I had a different question. I had two other questions, just because that you stimulated. The first, the first question I have is, related to the square root of -1 and the way we introduced the square root of -1 when we needed to complete an operation. And it gets back to your concept of balance zero, which is, we introduced square root of -1 because we realized because we couldn't take it in the real numbers, and so it was introduced. And in a strange sense, I wonder if we created when the creation of when people conceptualized negative numbers, or when they conceptualized subtraction, when did the negative numbers get conceptualized, and was 0 as a balance to complete those operations, was that introduced in a timely way? This is something historically I don't know.
So I'm not very sure about this.
Because the balance 0 idea, suggests the possibility of imbalance to one side, and it was something I leaned on in my own talk, but I don't know the history.
So if you ask that whether this balance nothing actually could be the philosophical foundation of 0, so I have tried to give two reasons that it should not be. One is that suppose if you put one thing I said, that if you define a number, any number, not only 0, any number, 7, 13 or 20, anything, by the difference of two numbers, that is a very bad way to define numbers. That will be to define number in a non-unique way, and that number is not independent number, that depends on other numbers. That's how it goes on. And then second thing is even more problematic, that if we define a number that way by subtraction, then I have to first define subtraction. I have to understand subtraction. For example, for 0, I have to know subtraction of, or any number, I have to define the subtraction of natural numbers before I define natural numbers. So I am defining a natural number by subtraction of two other natural numbers, which means that before defining natural number, I am defining the subtraction of natural numbers, which is self-contradictory. So first I define the number in its own right, and then I define the subtraction. That's my view. This is one thing. Second reason I gave, that if k minus k equal to 0, and that's the way I define 0, then I would say that I cannot have any idea that k minus k is 0 unless I know that 0 is based on nothing. So I should have the prior understanding that 0 is nothing, and then I can say k minus k equal to 0. So k minus k equal to 0 should be secondary to the primary idea of 0 based on nothing. So that's how I say that 0 comes as an independent number based on a philosophical base of nothing.
Sudip, Joe's question was not about 0, but about negative numbers, and when did they appear? It's a little bit away from our focus, but maybe it is relevant.
It was relevant to our focus. Sorry, let me just clarify. It was relevant to our focus only insofar as when one defines, if one defined, the natural numbers first, and then one defined subtraction, one could encounter subtraction in a way of, as I teach my child, 3 minus 5, and then how does one manage that? All of a sudden, one is forced, or not necessarily forced, but at some point one will come up with the notion of negative numbers, and in order to fill the gap, the 0 must then be introduced between -1 and +1, and that's why it's important for this conversation. In the same way that we introduced I as the square root of -1 to deal with operations, people bump into operations where they can no longer take the operation and therefore introduce new. And it was just a sort of a question. I mean, there's a should that Sudip is talking about, and I agree with your should, but the question is when and how were these things introduced? And so if we knew when people were conceptualizing negatives, and I do think, by the way, practical operations require negatives. For example, I owe you money, I owe you crop next year, as the case may be. Those things require some operation, a flow in some sense. But I'm not sure when these were defined.
Yeah, no, Joe, your point is well taken, and it's an interesting one that 0 might have suggested itself by the necessity to deal with the debts incurred. In fact, that's how negative numbers. We're not sure yet whether negative numbers are a very, very modern conception, that are an anachronism to be introduced now, because in those days there's clear record that people talked about debts, that you owe me this or you owe me that, and they weren't thinking in terms of a negative number, but they're simply about what you owe me or what I owe you. For us, you might say that's the same thing, but it isn't.
No, it's not.
A negative number is really a mathematical concept that may have arisen quite late in history. It's also one of the things we're running up against and discussing in our
Can I
group.
say a couple of words?
Please.
Say a couple of words?
Yeah, absolutely.
Yes.
The question was addressed to you.
So it is true that for centuries and millennia, people were very uncomfortable about negative numbers. But negative numbers and their operations were first mentioned again in the same book by Brahmagupta. The book name is Brahmagupta Siddhanta, which was written in 628 CE, where he gives the clear operations of negative numbers. It's not only addition and subtraction, but also multiplication. That was the first book which mentions the operations of negative numbers. And this book mentions that negative into negative is positive. And because of that particular statement, which is a kind of billion-dollar statement, out of that statement came out the imaginary numbers later. So negative into negative, what motivated him to say negative into negative is positive? That, of course, we do not know. But my idea is that negative was considered just as an opposite direction. Just as if there is a force, then there is opposite force, something like that, in opposite direction. So if we go left side and then come back again to left of left, then it's right, something like that. So this is the way I think it's a very simple philosophical or very simple way or understanding based on some very simple understanding. This operations of negative was ascertained in Brahmagupta's book, and that was taken as true. All of the people all over the world took it as true. They assumed, they never contended that negative into negative is positive. They just assumed that from Brahmagupta's book, which was written in 628 CE. And out of that came imaginary number. Now about this number line, you were saying about number line, it's actually came much later, that I want to go to negative, so I have to cross 0. I do not think that's the way 0 came. Because if you see even the phone, your mobile or phone, cell phone today, then also you see that 0 comes after 9. It is misplaced. So 0 in the number line, that was a much later idea, I think. And if you think about Descartes was actually the person in I think in 16th century CE in Europe who actually combined. Of course, in the Islamic world they did it, but more formally Descartes did it. He combined the algebra and geometry. He made this coordinate geometry. The Cartesian coordinate is very famous, and he was the first person, as we know now, of course it may not be true, who extended that axis, x-axis, up to 0, and later towards the negative side. Not by him, but by others. But he extended it up to 0. So the number line came much later.
Mm-hmm. Very late. Okay. Thank you. Thank you, Sudip.
Any follow-up, Joe?
No, I mean, I think that was great. That totally answered my question. I mean, I think Sudip, we're talking, it's definitely 628 or 1628 CE. So these are much later ideas. So I think that's a very solid argument for it.
Yeah. That seems to be what we're finding, is that modern authors are projecting their viewpoint on ancient civilizations, assuming that that they had the same mindset, which it absolutely complicates our research, because you really at some stage cannot take on face value with what has been written about the past, and hence the reason why we're trying to do fresh research, to go to the source and to be able to compare and contrast. Okay, Joe, you have no further questions?
No further questions. Thank you, Sudip.
All right. Mayank, you're
So there was this
Sudip is a younger
interesting discussion
associate of yours.
about the fact that you needed a philosophical foundation because mathematics, the mathematical zero is not an arithmetic zero in the sense that it is not required for arithmetic development. I just want to say two things. One thing is that the philosophical ideas of zero, of course, in India come from grammar and Nasadiya Sukta, etc., that he talked about. But there is also another angle to this is that mathematics was still treated as a language. Its use in algebra, its use in physical sciences is a later mapping, 16th century, in fact, as late as 16th century. So at that time, mathematics was used, so it would not be an unnatural thing for them to worry about this null in the mathematical sense and give it a zero. So that agrees well with what Sudip said. The second point that is that you sort of worry about mathematics in an abstraction and then play with it only as an abstract entity is again corroborated by many physical ideas. So, for example, I personally prefer Panini's example than Nasadiya Sukta simply because it is actually physical, where words and sounds disappear in every real sense of the word. The third is that I would have wondered whether even people outside India would have worried about the fact that 0 oranges and 0 apples mean the same thing. And somewhere along the line, somebody more perceptive would have worried about this issue that what is this number 0? Because these zeros are, I mean, wherever you apply, it gives you the same kind of an entity. And those issues sort of are there. So what Sudip said was nice. He said it well. And it agrees generally with the background, especially with Panini and with philosophy. And the case that he makes that mathematics never realized needed zero, I would say that it is slightly an exaggeration because when you go from arithmetic to algebra, zeros come in. You have so zeros of equations come much later, but essentially asymptotic values of functions, etc., do bring in zero. So I think there is an element of linguistic mathematics which would have encouraged zero in India. That's all I want to say.
Any questions? Any specific questions?
No, and no specific questions.
No. Okay. Ganapati, I explained to the others before that you were introduced to us by your interactions with Dr. Robert Lawrence Kuhn from Closer to Truth, with whom we also collaborate. And he apparently was very happy with what you were able to teach him about certain Indian schools of philosophy. So from that perspective, plus went from a computer scientist to an artist, I'm very curious to hear about your career as an artist also and how that maybe possibly relates to the invention of zero. But you've heard Sudip's presentation. Do you have any questions?
Yeah, I have a couple of questions. One is when Sudip, when you mentioned that in daily life there was no need for a zero. I was just wondering, there could have been situations like you borrow a loan and you repay it, and what is the balance, or you have some kind of statistics like what is the amount of crops that was harvested in a particular county in a particular season, or maybe like number of deaths due to a certain cause, and certainly there would have been the necessity to use zero somewhere. So I was just I mean I know it's not a very very candid reason, but I was just wondering, there would have been a genuine need for zero even in daily life.
Sudip?
I could not hear it properly, but because there were some disturbances. But I guess that the question is that, yeah, even in daily life, perhaps one would need zero because for balance. So today, what we say, if I want to say that I have no money, I can say also I have zero money. So in that sense, of course, so zero, the no, that is the absence or emptiness or balance were everywhere in all cultures. But the point is, there was no requirement. Nobody perhaps thought it was that it is required to invent a zero as a number, a mathematical zero, and then to consider its calculation, its mathematical operations, subtraction, etc. So one can always express that I have no work. I do not say, I need not say that I have zero work. Nowadays I can say this, but it was never required. So with the word no itself, every purpose was served, I would guess. So one would not need to invent a mathematical object, particularly a number which is at the same status of other mathematical numbers, natural numbers like zero, to mention that to conduct the day-to-day activity. And that is perhaps why that zero was not invented as a number, as a mathematical number in every culture.
That seems to be correct, judging by the presentation from the expert on Egyptian mathematics, where they also had to keep ledgers of expenses, assets, and debts. And if they balanced perfectly at the end, they would use this symbol called nefer, translated NFR, which simply means beautiful, or done, perfect, like that. It wasn't seen as a number as such. It was just a statement to say things are in balance. So that seems to confirm that, at least in the Egyptian case. I can't say otherwise, but I think Sudip's sense is probably correct, and it does show the long journey that people traveled before zero as a number finally enters the historical record. Something must have happened, because there was tens of thousands of years that people did without, and then there it is suddenly. And we don't know exactly how it came into being. If you look at the Mesopotamian case, how did that empty place, or the placeholder, the two slanted wedges that they used, that's from about third century BC as a placeholder. How did that figure into the transition between zero as a mere absence and zero as a fully fledged number? So we don't know yet, and our biggest enemy is the fact that there's a lack of evidence. So these are all the issues that we are facing, but we're trying to sort that out. Ganapati, any follow-up questions from your side?
A related question. I really like the classification of nothing into the four classes.
Could you speak up a little bit, please? Could you speak up a little bit?
Yeah, can you hear me now?
Yes.
Are you able to hear me now? Okay.
Yes.
So I really like the classification of the four classification of the four classes of nothing. And when you mentioned that Nirguna Brahman, non-existence nothing, right? The classification of non-existence nothing could have been a reason for the idea of zero coming into the picture. How do you conclude that Nirguna Brahman is non-existence nothing?
Again, rephrase. How you conclude what?
How we conclude that Nirguna Brahman is really non-existence? Is that the question?
That's the question, correct.
Sudip?
Can I answer that?
Okay.
It's simply a question of defining with neti. When you say define it, you say neti, not this, not that. And that is how they end up with the idea that it is nothing that is in existence.
So when you start the neti exercise, in order to figure out the ultimate reality, you're still left out with the person who's asking the question. The questioner is still existing. When you say neti, if you approach it from...
Yes,
all right. So let me give. There are two things. The first is about whether Nirguna Brahman is really the absolute non-existence. I do not think it is. I wrote in my slides that it is perhaps very close to non-existence. I do not think that they actually, through Nirguna Brahman, actually considered absolute non-existence. And here I would say that actually Chinese Taoism, they have a better absolute non-existence than Nirguna Brahman. But in China, of course, this was not translated into mathematical zero. So Nirguna Brahman is perhaps closest I could find in Indian context, and apart from the Nasadiya Shukta, which also says that the non-existence, but it is in the Indian words, Sanskrit, it's before Sanskrit. So it's called Sat and Asat. So it depends on the interpretation how you translate them. So it is very difficult to pinpoint that whether it is non-existence or not. And the second thing that when you say that yes, neti neti, but there is this speaker who says neti, so he remains. So that is always there. That is always there. So non-existence. When I say non-existence, I talk about absolute non-existence, but I very much know that I cannot think or speak about absolute non-existence, because whatever I think, or this is a philosophical thing, whatever I think or whatever I speak, are existence, definitely existence. So when I speak, when I think, it is by default, it is existent. So all I have is a notion of absolute non-existence, not the non-existence. I am not on non-existence, I am existence. So I cannot it's impossible for me to realize what non-existence is. This is by definition. So I can only have a notion of it. That's all I can say.
Ganapati, does that satisfy?
Yeah, I mean, when you mention it as close as you get, I think it makes sense.
Okay, and Sudip, then to follow up on that, the notion of absolute non-existence, that could have been the philosophical basis for the invention of the number zero. Is that right?
Yes, that's what I tried to say.
And so that's also one of the angles we're exploring, besides simply tangible evidence in the other cultures, is what their philosophical context was that may have informed their mathematics, because their mathematics obviously didn't evolve in a vacuum. It was part of a rich cultural mix, and so their philosophical ideas are also very important to take on board when you're exploring this. Again, there too, it's tough going, because not all these cultures had the same philosophical context to be able to compare and contrast. They have this, their creation myths, but they're also subject to interpretation. But we are taking that on board, not just the mathematics, but also the linguistic, the philosophical, and the religious. All of those ideas that mix, that constituted the intellectual climate of the day that educated mathematicians would have been acquainted with, may have contributed to that. That was actually, what my starting point was in the case of India, is that if you did have this rich classical culture and you had mathematicians who were conversant with the ancient text, the canon, then even subliminally, having this background would have helped for them to be able to conceptualize something as abstract as the mathematical zero. I maybe just divert momentarily. We have a cognitive scientist on board who has written an article, contributing an article, Andreas Nieder in Germany, who has done actual laboratory testing on animals and also on human brains, in the sense of measuring, with probes, the activities of the brain when numbers register. And believe it or not, but he concluded that, this has to be corroborated, but I assume that he's very meticulous, so that it probably will be. that the registration of the lower numbers, 1, 2, and 3, that there are actually dedicated neurons that are attuned to these simple numbers, 1, 2, and 3. And the whole edifice of even modern mathematics is built on our ability to be able to do that, to have brains that can process these simple numbers. And so his conclusion is that why was 0 so difficult to invent? It's because it represents the absence of stimuli. When you register 1, 2, or 3 in terms of objects or whatever, there's something empirical there, something that you can measure. But for the absence of stimuli, when the brain is in its rest state, to be able to then also conceptualize that this may be a functional category that may have its uses, that was a big jump. So he defines 4 stages, and this is the last stage that apparently, even though a lot of the animals can count simple numbers up to 3 or sometimes 4, or maybe even 5, like crows are very smart. They obviously never had occasion to actually, write down these concepts and these texts and elaborate on them. So humans seems to be the only ones to do that. I'm not saying it's not a value judgment that that's better or worse. If I see a pigeon fly by, I can't do that. Fly by my house at 80 miles an hour. The pigeon. I'm not saying the pigeon is better than I am or I'm worse than the pigeon is. It seems to be an empirical fact that this happened. So humans do have this ability, and it complicates matters in the sense that from another cognitive scientist, we heard that the brain doesn't even process stimuli as such, but the differences in stimuli. When you register one object, you register the object against a background. And so that background registers, and it's a steady background, it's a steady signal, which apparently your neurons register. And then the object against that background. So it measures, your brain actually processes the difference between stimuli. It's very interesting because that itself carries over into how we formulate our language by differences rather than absolutes. You do not identify an object in a positive sense. I believe in the Indian context they call this apoa. That you can only, that's where also the neti comes from, where you define an object by what it is not. And all the things that an object is not defines what the object is. So it does relate language to mathematics, and to Mayank's point of that mathematics began as a language, and maybe in India, maybe other places, where it was less of a practical use. So these are the things that we're encountering. It makes it all very interesting, and we'll have to see where we conclude. So we've heard the 3 panelists. I would like to ask Sudip. We usually wind up these sessions with three questions. If you would just answer them, a rapid fire, just one single word or sentence, no further explanation. Was the numeral 0, was it discovered or was it invented? Sudip?
If it's just one word, then it's invented.
Okay.
If it's a little more, then I could have said more.
No, let's keep it there because it's part of a survey, and we want to see where the consensus takes us. The second question, this transition between the placeholder 0 and the number 0, was it a gradual evolutionary process, or was it a disruptive moment in history?
Neither. As I argued, that placeholder perhaps didn't have any role.
Okay, perfect, great. And finally, this underlying concept of nothingness or emptiness, is it trivial or is it profound?
Profound.
You'll be interested to know that even there we find a lot of disagreement. But again, we'll get into that, sort it out, hopefully, and make some sort of an intelligible. Oh my goodness, I totally left Marcis out. I apologize, Marcis. It's not too late. It's not too late. It's the show is still recording. Marcia, please, you've heard all of this and my rambling. What would you add to the conversation? What questions would you have for Sudip?
Okay, first of all, I would like to thank Sudip for this, for his presentation, and for me as experimental physicist, it was a very interesting aspect which Sudip bring it to this discussion. But from viewpoint of experimental physicist, I would like to add another perspective actually, and question. When we are speaking and thinking about numbers, at the other extreme of number line, there is infinity. And when we are speaking about infinity from very old times, I guess maybe starting from Aristotle, we are thinking that there is actual infinity and potential infinity. And in some sense, what I was trying to discuss last time, 1 week ago, that also when we are thinking about zero, there is potential zero, and Sudip presented nice classifications like balance, absence, emptiness, nothingness. But I guess that there should be also a perspective to look at zero like actual zero and potential zero. So important, of course, it's much more late development when in 17th, 18th century calculus was invented. Then when we are thinking about operations on numbers, then these two potential zeros, for example, when we are speaking about instantaneous velocity, we are saying that displacement, which is approaching zero, is divided by time interval, which is approaching zero. So we are dividing two potential zeros and arriving at very specific number, which represents instantaneous velocity for some certain process. So I am wondering, and my question is, if we are looking in Indian perspective and Indian history, as I told already, in ancient Greece, starting from zero, there was this explicit or unexplicit discussion about potential zero. Is it something similar happening in India? Because in India, as you demonstrated and as we all know, approach to zero most kind of conceptual and philosophical. And this also is kind of a conceptual and philosophical angle. Was there something similar like potential zero?
Sudip?
Yeah, so I'm not very sure what you mean by potential zero. I heard the calculus, I heard the 0 by 0, and what is exactly potential zero? I'm not.
When you are dividing, for example, time interval in smaller and smaller parts, and finally arriving at something which is practically zero. And if you are dividing in infinite number of times, you are arriving at potential zero.
So yes, so it's basically the limit tending to zero you are talking about. There is a normal mathematical limit tending to zero.
Yeah.
So yes, I myself have a different view in this, but you didn't ask my view. You asked whether something like this was thought in India. In that case, I would say that there is a clear writing about what would be 1 by 0 in 12th century CE by Bhattacharya II or Bhattacharya, who says that 1 by 0 would be something with which if you add anything, it remains unchanged. So that's the definition of infinity. And if we go more than 1 millennium earlier, you would find that there are different schools of mathematics in India. One is connected to the Jain religion, a Jain sect of philosophy. In the Jain sect, they not only considered infinity, but also considered different levels of infinity, different dimensions of infinity, which was not considered in Europe before 19th century. In Europe, it was popularized by George Cantor in 19th century. But more than 2 millennia before that, different levels of infinity was considered in India by Jain school of mathematics. So these are some background about this limit, etc. Yes. So when the Indian mathematicians did notice in the later part of the, at least in the later part of the first millennium CE, I do not remember the name of the mathematician right now, but it's in the book which I have referred in my talk, and they actually considered that what would happen if the number becomes is in algebra. Suppose there is x, and if x becomes smaller and smaller, so it tends to 0, it becomes smaller and smaller. So those things, those limit, idea of limit was considered in the first millennium CE. And about calculus also, before it was invented in Europe, perhaps by Newton and Leibniz, 2 centuries before that, there was this Kerala school of mathematics in India, where they considered calculus in a very limited sense only for trigonometry. So all this actually gives some idea that that what you have asked, that is says a kind of limit and going gradually towards 0, etc., were in the mind of Indian mathematicians in various ways over the centuries and millennia.
Marcis, does that answer your question or not quite?
No, it's answered the question, and thank you very much.
But I'm curious because I've heard this before and I've actually read it. I don't remember the details now, but Passage, I think his name was. I think Kaspars mentions it in his paper. He cites Pesich, who also cites the ancient Greeks for having at least considered 0 as a number. It never blossomed into into mathematics, into the number. But you also mentioned this. Do you know more details about that? You said did they really consider 0 as a number, to your knowledge?
No, as far as I have read, of course, I haven't studied it like subject of studies, but in all the papers and books which I have read, it's always stated that they didn't have 0 and didn't consider. Although, if we are speaking about the 0 paradoxes, Zenon paradoxes,
right.
Of course, implicitly there is some idea that finally we are coming to 0. To nothing.
Yeah, Kaspars mentions Pestis, who refers to apparently Plato, who made some references that could be interpreted as meaning that counting should start at 0 and not at 1. So that's also something that we should definitely factor in. This is the only culture we do not have highly represented is the ancient Greeks, yet we have the Egyptians, the Mesopotamians, and there's some overlap there because the Greeks got their mathematics from the Egyptians and the Mesopotamians, but of course had their own independent thinkers. So we hope to complete the picture by having them as well at some stage. Okay, gentlemen, unless there's something else, we also want to keep it within the limits of about an hour and a half. Thank you all very much for joining. It was a very stimulating discussion presentation. It also happens to be the last session of this online event, and we will now launch into the publishing phase of the book project. So many thanks to you and to everyone else that has contributed to this, our online viewers, because we've really learned from each and every one of you. Thank you, and we will keep you informed through the website.
Thank you.